Welcome to tutorial 1302. This is video on demand consumption from workloads on Kubernetes Edge services. We're going to talk about some really cool things that you can do in this space, and I'll give you an example of why you might want to go down this path. Yesterday, I was sitting in a medical lobby, and we were waiting for patients to get served and whatnot, and there were 30 or 40 people in the room, and there were TVs on the wall. Nobody was watching it. What were they watching? Something on their phone or their tablet or their laptop. They were all streaming video from somewhere else. So that's what we're going to talk about. Let's go to the next slide, Jeffrey. Just as an introduction about myself, my name is Bryan Gartner. I'm a senior technology strategist at SUSE. Been there about a decade. I work with hardware partners, software partners, embedded partners. And I had the privilege of working with Jeffery. He is an excellent guy, and he's going to do an introduction and then start his presentation. Thank you.
Thank you, Bryan. Hi, this is Jeffery Du. I'm the Senior Principal Solution Architect in Ampere Computing. I have a 20 years of experience in the software industry. I joined Ampere and the hardware as the solution architect for providing the solution to my partner, to our customer, and also service providers. So we're going to share you one of our secret sauce on the video on demand streaming video product. In this POC, we're going to show you more. So back to the Bryan. So in this thing, we're going to show you our video on demand use case. And this kind of use case usually require several things. For example, the bitrate streaming. One of the other thing is transcoding conversion. So people are probably using H.264. That's a very popular codec. Maybe using the high performance device, they can use H.265. Or recently become very popular case codec called AV1. So those kind of conversion can have different bandwidth or different device computing power. Also, we also need to talk about the last mile for delivery. But usually, when you click the video or click the button to play the streaming from the cloud, you think it's not cloud, it's on the cloud, but it's not. It's actually come from the data center on your ISP, which is very close to your place. So that's something going to generate a lot of data directly that and a very low latency. In this kind of thing, we're going to talk about our tooling. So in this kind of genetic case, we're using a genetic Kubernetes cluster, and also adopt the container technology to wrap NGX web server for a hello world type, that's just like a front end. We also can including the VOD module service to do real time, just in time repackaging those MPEG-4 file into the video streaming format. Of course, we also need to consider to have a CDN in edge cloud infrastructure, so they can do much easier to offload the workload and to the close data center to customer. And in the other end, we also definitely consider how to measure the performance. So we're going to validate with a JMeter with HOS plugin. So on the topology wise, we also need to talk about from bottom up with the hardware to up to the software as a service. So in this kind of thing, we're going to mention about our crown jewel is Ampere Altra. It's 80 core with 68-bit on virtual 8.2 core per with 80 core per CPU. It is designed with a single thread cloud core, and it with consistent operating frequency and provide efficient power and also efficient area. So you can use it in multiple location use case. And also because the power with a large low latency private cache, they can boost out the computing as well. Also, we're using NVIDIA networking with Spectrum Switch SN 3700, and with the 32 port of the 200 gigabit per second ports. And on the server side, we're using Mellanox CX6 DS card which is with the one port, 200 gig per second physical port, they can support in crypto as well. In this case, we can deliver things in the large scale. So next time, we're going to switch to Bryan.
Thank you, Jeffrey. Yep, and as Jeffrey just mentioned, he talked about the hardware and the networking layer and things like that. And we're going to deploy these even in an edge space, or it could be an ISP data space, or it could be at the bottom of a cell tower, wherever. But what you need to do now is you need to have an operating system. You need to have something in the Kubernetes space and things like a storage and whatnot, and being able to manage all of these devices. So if you look at this portfolio, I've kind of highlighted the ones that are there. One in the operating space is called SUSE Micro. It's very secure and very focused on the edge stuff for running containerized workloads or running Kubernetes where you can run the pods and whatnot. And then at the Kubernetes level, we have K3S, which is very focused again on the edge, very simplified, very easy to deploy. And there's also the Longhorn piece, which allows you to do block storage things, because you realize that videos are going to use a lot of storage stuff, right? And you need to make things go on the fly. But once you have these nodes all over the place, you need to manage that, and that's with SUSE Rancher. So next slide, please, Jeffrey. And what I wanted to do is kind of go over the ordering of how you deploy this, and again, why you want to do that. So again, with the operating system, SUSE Micro, one of the things that it's very capable of is security, and it's very lightweight, and it has an immutable root file system. So now from a security aspect, you can run your workloads however you need to, but you don't have to worry about securing a lot of other stuff because it's already built into that. Then again, with K3S, again, very lightweight, very easy to deploy, and with that Longhorn block storage, now even if you get over the fact of being in a 12-factor ephemeral thing of containers and whatnot, you probably need to have some storage where you have input of where the source file came from and how to quickly convert it to what we need to do. And again, with the SUSE Rancher, then I can manage those clusters, because again, if you look at the top, I said that we're going to probably deploy a 3-node cluster. And then with the next line, that's going to be a trigger of what we do with K3S, because by default, it comes with traffic as the ingress controller. But instead, we're going to use ingress, and Nginx is the ingress controller. Because as you see farther down, we're going to deploy more Nginx things, that Hello Web App, the VOD, the Video On Demand module, and the persistent volume claims are going to use the storage class provided by Longhorn to give them that information and that data store that they need. And one thing I'll mention just on the bottom, but even we're going to cover in a more detailed perspective in another section, is how do you measure the performance and the benchmarking with something like JMeter as a container to go ahead and keep track of and also initiate more of these calls so that you can figure out how capable your system is. Next slide, please, Jeffrey. This is more of the graphical representation. And again, I mentioned it was a 3-node cluster. Again, there is the roles that are on each one of the nodes, the control plane, the etcd, the worker, the agent. There's Longhorn there across all of those nodes, so you have a resiliency, and you can start to see how this becomes a very resilient cluster. If one node goes away, no problem. It's still going to keep them running, because Kubernetes says, you told Kubernetes I need to have this many things running. It just moves it over and runs it on the other 2 nodes that are left until you fix the node, okay? Or the node comes back online after a reboot. That's fine. And that K3S is the Kubernetes that's running there. But you can also see how this ties together into that networking space, that we had 2 different network interfaces, the 200 gigabit and also the 1 gigabit, and that Mellanox switch that did things. So the Rancher and the upstream grabbing more data and stuff, it can come from that, but even the clusters can talk together very fast and do what they need to do. And then also there's some other services that might be there, like the HA proxy service, and of course, like the install services. How do you make this happen with DHCP, DNS, or TFTP, like for Pixie booting? But that's the easy way that you can make all of this happen. And then I'm going to hand it back to Jeffrey, because now he's going to talk about the workloads that are actually going to run on this.
Thank you, Bryan. So in this section, we're going to talk about video on demand workload, how we're going to deploy. The POC including 2 parts. One part is the front-end page. So which means this is going to deploy the NGX web server along with the application like YouTube, like a homepage. So they can show the thumbnail, they can clickable to the destiny page. That one contain a video playback, video player with HTML5 support. So on the deeper side, they have the other service called NGX VOD container. That one provide adult B-rate streaming capability and also provide repackaging, just-in-time repackaging to dissect original MP4 file into the segment for the playback, and also picking out the subtitle like VTT, and to serve the subtitle during the playback. Of course, this is thumbnail also support the front end to provide what kind of video you're going to choose, not only just um, based on the short paragraph to explain the video clips, they also can see some kind of easy to see preview with a thumbnail. So in this kind of thing, we're going to show you some demo. It's a recorded video, so let you see how, let you know how we're going to present it and also deploy things on Rancher. In this here, we usually starting to the thing, and once you click into the K3s cluster, you're going to see overview, and also going to show you this is a 3-node cluster, and we have workload deploy. We're using deploy YAML file to deploy Hello app and also VOD service. And this thing, we're going to show you the part they deploy, which cluster they are. So in that, we're also, before that, we're also using the Longhorn to create the persistent value first. Every time the deploy out, will find the persistent value with the different app notation that will match each other. So when they bring out the part, they will go run automatically. With Longhorn, this thing we're using the path called var/lab/Longhorn as their partition and resource. So they're using the one to work on the iSCSI daemon to synchronize things together and also manage the replication. And in this side, we're also using Grafana with the permit fields to do telemetrics. And this one will show you how the CPU loading, how we're going to show you seeing stuff. We're going to show more on the delivery. So we're going to chop to the service. If we go to the ingress, you're going to see have a link to show our demo website. The demo site, we click one of the things is our Ampere AI to talk about our head of AI. In the Ampere is Victor, and he also showing the demo. In this demo, you probably see, this is using MP4 file in behind the through streaming. No, I show you in the guts. Currently, you see the right-hand side is using the Chrome browser inspector. So you're going to show each component they download from the thing. And the first thing is showing the master playlist in the N3U8 format, and also showing the individual profile for playlist. This thing going to showing you this actually download the file to do which profiling to do playback. And of course, you're going to see the VTT file being chunked in small chunks, chunk to show that period of time the subtitle. And the other demo we're using the dash protocol. So this one using MPD extension. That was XML format. Of course, they also support the subtitle with the VTT file. And since this demo is kind of short, they condense everything together. So this is a very effective way to show the customer. Since they're using HTML, they're using HTML video player, that people don't have any problem using any device to do playback. So in this slide, we're going to tell you more Azure Cloud topology, how they interact together. On the left-hand side, the content manager usually pick and choose the hardest, or you desire watch the video or a movie. So they're going to put into the destination storage, waiting for the VOD module to pick out the content to do repackaging. So in this case, we're using manual pick with wget to get the content to local store to put into PVC. Then once the trigger from the audience say, hey, I want to see our Ampere AI video. Once they click the button, the player will retrieve the the master playlist. Then they grab out all the content all together. Of course, on the right hand side, the Hello app is going to provide you HTML5 player. They can handle those kind of HLS or Dash protocol player without any trouble. So we're going to elaborate more why the adult B-rate streaming is effective for the people, especially for all of us. So consider you have a different network situation. Your ISP or the mobile network you're using have some kind of a latency, have some kind of a blocking that cannot provide high bandwidth to you. At that time, you probably only have a 50 gig per second, but still can watch a movie non-stop. Um, then you can still can when the connection goes back, connect in good condition, so you can watch in high quality. They can deliver that. So your HTML5 video player can help you to do the streaming. So in the case, we can consider you're driving a car, you have the kids in the backseat using digital device as a digital nanny, right? So when they watch a movie from one to one, they suddenly go past by a mountain. They have a reception issue, so they can only get very minimal bandwidth. So in the slow internet section, your movie is still running. Your kids not complaining. You can happily driving all the time. Until you pass the mountain, reception go back to the good condition. Your player will get the best quality for video for the segment for the playback. So it's everybody happy. Um, just like Bryan talked about, we're doing using certain tool to do benchmarking. So the JMeter is the trusted. We can use that one to test all kind of web application. In this case, it's a little bit different because this is a video on demand, video streaming. Whenever we're doing streaming, they have a master playlist. They have audio. They have audio section. They also have a subtitle section. Everything going to trigger us in sequence. So it's not like a regular HTTP request. You need to have understand VOD and protocol. So in this plugin, it can support HOS also Ampere Dash. So in this test plan, we show you the portion is how we control the thread group, and in here is a continuous thread group that we're handling, but only do 10 thread first. In the runtime time is only 10 milliseconds with the 5 loops. So this is you see probably this is something else pretty in the slow movement, not much simpler going to trigger. Yes, this is something else that we just try to test water, make sure it's no problem. In real case, we testing, we choosing 1,000 thread. At the same time, the rampage time only will be 200 milliseconds with 10 loops. So you're going to imagine how the bandwidth we can do in this single compact cluster. And currently, our test environment is under not under the optimization, which means we didn't using jumbo frame. NTU is still 5000, and we didn't do only tuning on the server side or switch side. And so everything will be using streaming with the HLS and also MPEG Dash with the maxima profile and also minima profile. So you can see the currently is showing you everything it can complete with 307,000 samples in 3 minutes, zero error rate. And responding time average is about under 70 milliseconds and 23 milliseconds in 95%. The throughput is about 1,830 transactions per second. As you see the diagram in on the bottom one, they're showing perfectly the last the audio section or subtitle section is hitting 25 milliseconds. So that's something information you probably want to know. So we're going to share more insights since we're showing you Grafana how to tracking the telemetrics. So doing the benchmark, we're also using Grafana to do system loading track. So currently you see is one of the time we're using the node tracking with our system. So you see this one with node and path information all together. So we can click the three nodes all together. They can show everything, and also back to the time frame about 6 hours later earlier, which is our time we're doing the testing. So we wash out the part information. We choosing that one was NGX ingress and also NGX VOD app. So those two will tell you exactly the major loading come from. So as ingress, the maximum top is probably 110% for the CPU core, and the NGS probably lower than 5%. On the memory usage, you probably is total usage is less than 10 giga, but the memory usage on the ingress is about under 500, and the VOD is probably under 400 something. And for the summary, we'll get back to the Bryan.
Thank you very much, Jeffrey. Yeah, and I was nodding my head because, again, I live in a rural place, so my latency and my bandwidth is orders of magnitude less than my peers that live in the cities and stuff. So yeah, I can leverage this video on demand. And if you look at kind of the industry overall about where this is growing and whatnot, for instance, like Fortune Business Insights and whatnot, they've shown that the market size value is around 370 billion last year, and it's already 470 predicted for this year, and it's growing to 1,700 billion by the end of this decade. So it's basically growing 20% each period. And there are lots of companies that are starting to go down this path and wanting to move into this video on demand and use this technology. Companies like Netflix, Disney Plus for streaming or whatnot, or even the social media things like Meta or YouTube. So with that, Jeffrey, let's go to the next slide. I can't explain how much popular this is becoming. Again, like that medical thing that I mentioned earlier, everybody's using their devices. And it's funny, even when your family comes over for dinner and then you watch TV afterwards, they're all watching videos on their phone while you're sitting in the same room. Okay. This is happening over and over. And just like Jeffrey gave that great example of the car drive, kids in the back are always watching something like that. And yes, we drive through a mountain pass, we have that issue. So the range of devices is growing. Okay. And it's going to keep growing in that space. And the mobility of it is a given. And of course, the latency or whatever the bandwidth needs to be addressed. And if this video on demand makes it so that I can stream and see what I need to see or what I want to see anytime, that's awesome. And what we've described here is using very much open source components for all those containerized microservices that are running on Kubernetes, like on SUSE Rancher, like on the K3S, utilizing things like the block storage from Longhorn. But even more importantly, too, are platforms like the Ampere Altra as well, and the NVIDIA networking stuff. Those are very good because they are very performant, in fact, high performance stuff. And because they have like 80 cores and whatnot, they do things very well. But even the performance aspect is also enhanced because the power utilization is way less. So it might be twice as fast performance wise and half the power. So now that means I could put those things all over the place. Okay. And there's also the cost too. It's much lower than really high mission critical systems. So even in this edge space, you can do something very resilient, like we said, with a 3-node cluster on this platform. Next slide, Jeffrey. And of course, like I always mention with software, it's never done. There's just releases. And this was our POC release, Jeffrey. We did this, we got this working. And of course, we learned, hey, we'd like to try this, that, and the other. Some of the things are listed here. So we know that in the video space, it might be really relevant to do something like object storage. And we might do that with MinIO and deploy that operator and use that technology to have object storage and also be able to connect to, gee, where are those source videos at? On a CSP somewhere, like an S3 or something like that. Okay. And as you know, Jeffrey and I did a lot of this work, and he did a lot of the manifest and the YAML files. We want to make it so that in a GitOps kind of approach, we can create something like that. Then we can have a CI/CD pipeline to test it and make sure it's all working. And then literally be able to push a button and say, yep, I want to deploy it on every cluster in this entire continent. Okay. And that's what's possible with something like Fleet, which is part of SUSE Rancher. because you can basically say labeling of the Kubernetes clusters, and you can say, nope, that's the dev cluster. That's where I want it deployed. No, it's already passing the CI/CD. Even like the stuff we have is already working. I want it deployed on all the production clusters everywhere. Next slide. And of course, I want to reach out to you and let you know that you can reach out to us if you have any questions. If this is of interest to you, we can show you what it's done. We can kind of give you access to some of this stuff. But here's a lot of the reference URLs that you can go discover this, learn about it on your own, play with it, try it. But again, you can reach out to us anytime. And with that, I'm going to hand it back to you, Jeffrey, if there's anything you'd like to bring up. And before we say goodbye.
Hi, thank you, Bryan. Thank you. Also, invite me to join this session to bring this our VOD POC to the customer, to the potential customer, and also you developers. If you're interested in this thing, using our ARM-based CPU, Ampere Altra, to build your platform with the low power consumption, with a low cost platform to make you most effective solution to your company. Thank you. Thank you very much.